pick the single most important topic in software development, it would be data structures. You can think of it as a fundamental tool that is available to every computer programmer. While programming, you can use data structures to store and organize the data. Hey everyone, this is Neha from Edureka, and in this session, I'll talk about the data structures in Java. Let's have a look at the agenda for this session. First, I will tell you what are data structures in Java. Next, I'll talk about the various types of data structures, that is linear and hierarchical data structures. So in case of linear data structures, I'll talk about the stack, queue, and linked list. And next, I will brief you about the hierarchical data structures, which comprise of binary tree, hash map, and binary heap as well. So I will be explaining all these data structures along with an example. I hope you found agenda interesting. Now, without wasting any further time, let's get straight into the module. First, let's understand what are data structures in Java. A data structure is a way of storing and organizing the data in a computer so that it can be used efficiently. It provides a means to manage large amounts of data efficiently. And efficient data structures are key to designing efficient algorithms. Next, we have two types of data structures, that is linear and hierarchical. So what is linear data structures? Linear data structures are those whose elements are sequential and ordered in a way so that there is only one first element and has only one next element. There is only last element and has no previous element, while all the other elements have a next and a previous element. Understood? Like you can have only first and a next element, and there is only last element but has only one previous element. So there cannot be any multiple previous elements or multiple next elements. Okay? But all the other elements have a next and a previous element. Note that there is only one previous and next elements. Simple. So based on these categories, linear data structure are being divided into stack, queue, and linked list. Now talking about the stack. Stack is an abstract data structure. It is a collection of objects that are inserted and removed according to the last in first out principle, that is LIFO. Objects can be inserted into a stack at any point of time, but only the most recently inserted, that is the last object, can be removed at any time. So you can see here, this is a bottom element and this is a top element. When you push the element into the stack, it goes into the bottom. And the last element, that is the top element, can be popped out. So once the top element is popped out, the next element which is available in the stack can be popped out. But the bottom element cannot be popped out first. Understood? So this is how it works. That is, it is an ordered list in which insertion and deletion can be performed at only one end, that is the top. It is a recursive data structure with a pointer to its top element. It supports two fundamental methods, that is push, that is you can insert the element to the top of the stack, and pop, remove and return the top element onto the stack. So if I have to give you an example, it can be reversing a word to check the correctness of a parenthesis sequence, implementing back functionality in browsers, and many more. Now let's see a small example of stack. So I have created a class called stack, and the maximum capacity of the stack is 1000. And as I told, we need an element called top, right? Because it's a main thing. So that's the reason. And then I'm initializing the maximum size of stack. So there are two conditions. First is empty. So if the stack is empty, then return top less than 0. Because there is no element in the top. When stack itself is empty, then there is nothing, right? That's the reason. And then I'm creating a constructor for stack and initializing the top size to -1 because nothing is there. Next, what I'm doing, I'm pushing the element into the stack. So if top is greater than or equal to maximum size -1, then print stack overflow. Return false. Else, insert the element to the top of the stack and initialize it to the variable, that is x, which is this one. Next, say that, so this element, which is the element that you have inserted into the stack, is pushed into the stack, okay? Then return. Then again, I'm creating a method called pop, that is removing the element out of the stack. So if top is less than 0, then say stack underflow. Else int x is equal to delete one element from the stack, that is a of top minus minus. Then return x. Again, I'm creating one more method called peak. If top is less than 0, then say stack underflow. Else return the element at the top of the stack and send it to x. That is the element which you have taken it over here. Simple. Now I'm writing a driver code, that is the main method. I'm initializing a stack and creating an object of a new stack and sending elements push 10, push 20 and push 30. And then when all these elements are inserted into the stack, if I want again, I can, say push 40. So when I use s.pop, so what do you think? Will this element will be popped out first or this element? Obviously this element, right? So now let's run and check for the output. So you can see first 10 was pushed into the stack, 20 was pushed, 30 was pushed into the stack, and then 40. But when I used s.pop, the last element was popped out. So if I don't have this element, I'll just save this. Now see, the last element, which is 30, is popped out from the stack, right? So this is how you can execute your stack, and these are the operations that is performed on a stack. So this is how it works. Now talking about the next data structure, that is queue. Queue is also another type of abstract data structure. Unlike a stack, the queue is a collection of objects that are inserted and removed according to first in first out principle. That is, elements can be inserted at any point of time, but only the element that has been in the queue the longest can be removed at any time. So you can see here it has two ends, that is front end and back end, that is the front end and the rear end. So if you insert an element, it goes to the front and that can be popped out, that is removed. But in case of stack, it is last in first out. In case of queue, it is first in first out. It supports two most fundamentals, that is NQ and DQ. NQ means you have to insert the element at E, that is at the rear of the queue. And DQ means remove and return the element from the front of the queue. So whatever element you insert at the rear end will go to front as soon as you insert it more, right? So simple, that can be taken off from the queue end. So queues are used in the asynchronous transfer of data between two processes. That is CPU scheduling, disk scheduling, and other situations where resources are shared among the multiple users and served on first come first served basis. So these are some of the situations where queue can be used. Okay. So now let's take an example and understand how it works. So this is very simple. I have created a class called queue and I'm creating a string of queue and assigning it to a linked list. So what I'm doing is I'm using queue.add and I'm adding all the 4 elements and then displaying the elements present in the queue. So when I say queue.remove of 3, it will display the elements present in the queue and the queue size and says whether it contains the element 2 or not. If yes, it displays that. Let's run and check the output. So first, when I print this, it displays the size. And let me tell you one thing, this is an inbuilt function. So that is the reason when I'm using add, it is being added automatically. So then what I did, I removed the element 3. So you can see here, I can remove any element. It's not that the element which is there at the last or the element that is there at the top or nothing like that. You can just remove the element from any corner. And then when I remove the element and I print the queue, it says only the remaining elements, that is 1, 2, and 4. Next, queue sizes, queue.size, that is 3. And then whether does it contain the element 2 in the queue? Yes, true. If I say element 3 in the queue, it should say false because I have popped it out, right? So let's see what it says. It says true because initially in the queue it was present. So if I now say element 5, then run. So when I say queue.contains 5, it should say false because it's not there in the list, right? See, it's telling false. So this is how you can perform the operations on the queue. The next data structure is linked list. A linked list is a linear data structure with the collection of multiple nodes where each element stores its own data and a pointer to the location of the next element. The last link in a linked list points to null, indicating the end of the chain. Element in a linked list is called a node. The first node is the head and the last node is a tail. So there are three types of linked list. One is singly linked list, that is unidirectional, where it contains only the information of the next node. So when it comes to doubly linked list, it contains the information of the next node, also the pointer to a previous node. And when it comes to circular linked list, head points to a tail and the last node points to the first element of the first node. That is, the last element of the last node points to the first element of the first node. So if I have to tell an example, so imagine a linked list like a chain of paper clips and they are linked together. You can easily add another paper clip to the top or bottom. It's even quick to insert one in the middle. All you have to do is you have to just disconnect the chain at the middle, add the new paper clip, then reconnect the other half. A linked list is a similar way of doing all these operations. Let's take a small example and understand this in a better way. So I have created a class called linked list example and node head is the head of the list. And I have created a class called static node. The inner class is made static so that main can access it. That is, the main method can access it. So I have the data and the next node. And the constructor for the node is int d because data is equal to d and next should be assigned to null. Now the next step is to insert a new node. So for that what I'm doing, I'm creating a static method for linked list example and I'm inserting linked list example list and int data. And I have to create a new node with the given data. So what I'm doing, I'm creating a new node with the data and assigning the next node to null because that is mandatory. So if the linked list is empty, then make the new node as head. So if linked list is empty, that is if list.head is equal to null, then make the new node as head. That is new node is equal to head. Else traverse till the last node. That is node last is equal to list.head. And then insert the new node. Again, insert the new node at the last node. And finally, you have to return the list by head. Okay. Now, this is a method to print the linked list. So current node is equal to list.head. And the linked list contains the elements that is being present in the current node and the list that is already being inserted. So when I have to traverse to the linked list, I'll check whether current node is not equal to null. If it is not equal to null, then print the data at the current node using the statement. Or else go to the next node. In the main method, I'm creating an object of a new linked list and I'm inserting the values into the list in sequence. Then finally, I'm printing the list. Okay. So now let's run and check the output. So see, the elements are being inserted in the sequential order. So this is how it works. So this was all about the linear data structures. Now moving further, we have hierarchical data structures which comprise of binary tree, binary heap and hash map as well. So binary tree is a hierarchical tree data structure in which each node has at most two children, which are referred to as left child and the right child. Each binary tree has a group of nodes, that is root node, left subtree and the right subtree. The root node is the topmost node and often referred to as main node because all the other nodes can be reached from the root. And left subtree and the right subtree is also a binary tree. And binary tree can be traversed in two ways, that is depth first traversal, that is in order, pre-order and post-order, and breadth first traversal, that is level order traversal. And the complexity is big O of n, and the maximum number of nodes at level L is 2 raised to the power L minus 1. And binary search applications include, it can be used in many search applications where data is constantly entering and leaving. Also as a workflow for compositing digital images for visual effects. Used in almost every high bandwidth router for storing router tables. Also used in wireless networking and memory allocation. Also used in compression algorithms and many more. So this is all about the binary tree. Now talking about the heap, it's a complete binary tree which answers to the heap property. In simple terms, it is a variation of a binary tree with the properties like a tree is said to be complete if all its levels except the possibly the deepest are complete. The property of the binary tree makes it suitable to be stored in an array. It follows heap property, that is, a binary heap is either a min heap or max heap. Min heap is for every node in a heap, node's value is lesser than or equals to value of the children. Maximum binary heap is for every node in a heap, the node's value is greater than or equal to values of a children. And popular applications of binary heap include implementing efficient priority queues, efficiently finding the k smallest elements in an array, and many more. The next concept is hash tables. Imagine that you have an object and you want to assign a key to it to make searching very easy. To store that key value pair, you can use a simple array like a data structure where keys, that is integers, can be used directly as an index to store data values. However, in cases where the keys are too large and cannot be used directly as an index, a technique called hashing is used. In hashing, the large keys are converted into small keys by using hash functions. The values are then stored in a data structure called a hash table. A hash table is a data structure that implements a dictionary ADT, that is a structure that can map unique keys to values. In general, a hash table has two components, one bucket array and the hash function. A bucket array for a hash table is an array A of size n where each cell of A is thought of as a bucket, that is the collection of key value pairs. The integer n defines the capacity of the array. Next, hash function. It is any function that maps each key k in our map to an integer in the range 0, n minus 1, where n is the capacity of the bucket array for the table. When we put objects into a hash table, it is possible that different objects might have the same hash code, and this concept is called as collision. To deal with a collision, there are techniques like chaining and open addressing. So these are some of the most basics and frequently used data structures in Java. Now that you are aware of these, you can start implementing them in your Java programs. So I hope you understood the concept of linear and hierarchical data structures. With this, we come to an end of this session. I hope you understood this. If you have any queries, you can comment in the comment section below and we will revert at the earliest. That's all for this session. I hope you enjoyed it. Thank you and have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!